Hello, guys. Good evening. I hope everyone is doing good today. And today we are covering up the 12th video of this data engineering series. And in the previous video, I continued a video like for 25 minutes, but there was a random glitch in my system, so I had to discontinue. But do not worry, I'll be continuing from the beginning so that you don't miss out on any of the key concepts that we discussed yesterday. And before we jump to the video, who are we? We are Data Valley, the fastest growing edtech company of 2025. And we offer you with IT solutions, trainings, and placement support. And if you're wondering what kind of IT solutions that we provide, it depends on your business use case. So whatever setup of company that you have, and if you need people who can take the job from day one, yes, we do have a talent pool of people who can readily take over the job from day one. So we have a talented people from our training institute itself, and we have almost people across different domains. So depending on your business use case, all you have to address, and we are ready to provide you with talent people. And then trainings. If you are thinking you need training support rather than getting placed somewhere, yes, we do provide you with training support as well. And if you're wondering what stream or what domain we focus on, we focus on multiple streams of subjects. For example, data analyst, data engineering, data science, Selenium developer, SQL developer, Java developer, Python developer, software engineer, QA tester, so stack developer, web development. So honestly speaking, we have all the hot in demand subjects in our training institute, and you can check out the curriculum in our website at datavalley.ai, and those are to the current standards, and you can be sure that they'll equip you with a knowledge that is required in the industry currently. And does your training end with just the training program? No, you also get the 100% placement assistance. So we provide you training with all your uh, you know the scenario based questions, interview questions, and system design questions. So whatever is not just your subject, but on top of that, we also train you with the necessary skills that you need to communicate and get over your job, get your first job. Okay, so that is all from us, Data Valley. And before we jump to the video, who am I? Myself, Franklin. I've got almost 3+ years of experience as a data engineer, and I'm super excited to get to see you all through this video, and I hope you all make most out of this. And I'm very sure that you all know the routine, what you have to do. Grab a cup of coffee, have your notes ready, and stay tuned for another 1 hour. Be focused. If you have any questions, drop your questions in the comment section. I'll be more than happy to address them. If I couldn't, in the later videos, I will try to address them to you. If you like this content, do like and do click on the bell icon as well so that you don't miss out on any regular updates from this channel. So, what are we going to talk in today's data engineering series? So, this is our data engineering series number 12. And what are we going to cover today is all about AWS Glue. You might be wondering, yes, I discussed AWS Glue video in data engineering series number 11, and why is this getting repeated again? If you remember, in data engineering series number 11, all we discussed was basic concepts, the fundamentals, the components. So we discussed those kind of questions. But in this video, we are going bit advanced, and we'll be covering up practical applications and designs. Okay, so this is going to be one step forward, an advanced concept to our previous video. So I ask you all to pay attention and be prepared for your upcoming interview. So the first question on our practical application and design part is that describe the process of creating an AWS Glue ETL job from source to target. So what is the thing that we are going to discuss in this? We are going to discuss the process of creating an AWS Glue ETL job, and this ETL job is from your source to your target. So basically, from a source to target, you are designing an ETL job. And one key thing that you know, you have to pay attention to this question is that I'm describing the process. I'm not describing about the ETL from a source to target, but from a source to target, what is the process to create an ETL job? So that is a key thing here. So even when you go for an interview, you would be expected to answer not what is what, but you are expected to answer how are the things getting done, why do you use particular strategies, why you came up with such a plan or an idea. So your thought process should be always how and why. Okay, and today we'll be talking about the process, so that should be your how. Okay, we'll come to this image later, and maybe at the end of this session I will try to get to this so that you get a broad summary or an idea. For now we will jump into the content straight away. Creating an AWS Glue ETL, which stands for extract transform load job, involves a sequence of steps to move and process data from a source to a target destination. So talking about the ETL design, it is never a point to point or a one step progress. Okay, it is a sequence of steps that are put together, and then your process begins. Okay, so it's not one step. So ETL job is not a one step process, but it is a sequence of steps that come together to perform the extract, the transformation, and the loading part. All right, so the first thing that we are going to see in here is the data cataloging, or in other words you can call it as source definition. So what happens in this phase? So even to perform your ETL job, so what is the first part of your ETL? The extract. So you want to extract the data. So what is something that you need to define even before the extract part? So you need to know about the source, right? You need to know what is your data. You need to know where your data is actually residing and how you can try to get a metadata for those tables. And that is where your starting point is, right? So it's not just you have a source, you just take it straight away. No, you've got to define your source. Okay, so that is where I've defined it as source definition. The key thing for your source definition using AWS Glue is that you must use AWS Glue crawler. If you remember, what does a glue crawler do? Glue crawler crawls through the data stores, and then it gets you the table definition, the schema definition, and other details, right? So the first thing we are doing here is that we are using AWS Glue crawler to discover the schema. All right, and if you remember the process, the glue crawler crawls through your data store. It gets the metadata information like schema, data, and table definition, and this metadata is passed on to your Glue data catalog. Why is that? Because AWS Glue data catalog is a repository, right? It's a metadata repository, and all this information gets put in there. Okay, so your AWS Glue caller is used to discover the schema and structure of your source data, whether it resides in AWS S3 or a JDBC compliant databases or other supported data stores. Okay, the crawler creates metadata tables in AWS Glue data catalog, which acts as a centralized repository for data definitions. And then, if you don't prefer using crawler, so crawler can automatically get an idea about your data, right? It automatically gets a some idea about your source and everything. But what if you don't want to use a crawler? So that is where your manual table definition comes into play. So as the name suggests, what you do is you will manually define your tables. You will manually define the schema. Okay, so inside the AWS Glue data catalog, you will be defining all these informations And there is one key thing I would like to address here. You must manually input your table definition only if you have a strong understanding of your data structure. All right. So if you are not sure about your data structure, if you're not sure about your table definition or a schema definition, just leave it to the crawler to do the job. It will do it perfectly. So, okay, it does everything automatically. You don't have to worry about it. But if you have a clear understanding of what you're going to do, then okay, go for your manual table definition. And then once you have defined your source, the next phase is creating your ETL job. Okay. So to create the ETL job, there are two things that you can do. One, you can use an AWS Glue Studio. Sorry about that. Yeah, you can use an AWS Glue Studio, or you can use scripting. So what is the difference here? I need to create an ETL job. So what is the difference between using AWS Glue Studio and a scripting mode? Okay, here is the difference. You can create an ETL job visually using AWS Glue Studio's drag and drop interface or by writing custom PySpark or Scala script. So what's happening here is when you use AWS Glue Studio, you are going to create your ETL job using an visual interface. So how does this AWS Glue Studio look like? So it has all the options like a button. So you'll have an option like add column, remove column, change data type, cast it to particular data type, and this is the format I prefer. So you will be having all these kind of transformation steps in an button format. So all you do is you just drag it and drop it to your ETL flow. Okay, so you will finally have an visually visually seeable ETL pipeline. But would you prefer it as a developer? It's not that you cannot use it or you shouldn't use it, but any proper developer, any proper PySpark developer, any proper data engineer wouldn't prefer any visual interface, but rather they will always focus on code. Okay, so that is where your script editing comes into play. So when you just go into AWS Glue, you have an option to write your own scripts. So you can either write your scripts in Python or Scala. So the choice is yours. So you write your custom code in your own preferred language. So that is the key difference between AWS Glue Studio and AWS Glue Script Editor. And here are certain job configurations that you must set. The first one is source selection. So you define the source or you define the location where your data is residing and you reference those tables created in the AWS data catalog. So once your crawler runs in, these metadata are passed on to your data catalog, right? So these tables are referenced directly. So you define, for example, if your Glue data catalog is your source, you define that as your source. And then the transformation phase. So your selection is done. Now, in the transformation phase, you will apply all kinds of transformations that you want to be done in your extracted data. Okay, so it can include like adding a column, removing a column, filtering certain rows, joining two tables, aggregating certain columns, or schema modification. So it all depends on your business use case requirement. Okay, so you do all the transformation, therefore enriching the data. And then the target configuration. So this is the third part within your ETL scripting. So you specify the target destination for the transformed data, including the data store. Example, Amazon S3 Data Lake, Amazon Redshift, JDBC databases. So as you have multiple sources, in similar, there are chances that you have multiple targets as well. I might need to write my data to a warehouse. You might need to write your data into a database. So it all depends upon the business use case. So what does your business use case say? Do they want to have it in the inbuilt data warehouse? Go for AWS Redshift. If they want you to store it somewhere else, but a cloud-based data warehouse, go for a Snowflake. You can go for Databricks. You have multiple options, right? So you define what is your target. Okay, I want to write the target somewhere. Do I need to set something else as well? Yes, you can define the format of your data. So for example, once when your data file drops in, mostly it is in of a CSV file format or an XML or a JSON format, right? And for a better performance and optimization, you might be changing the data to an Parquet format, right? That is what is preferred usually in the data engineering domain. And once you have all done the transformations using the, you know, in your extracted data, then you have an option. How would you like to store it? So how would you want to load it into a particular different warehouse or a data lake or a database? So that is where you decide, do I want to store it in a Parquet format or a ORC format? So optimized row columnar, that is ORC. Or you define, should I just put it as a CSV again? Okay. And even with all those file formats on top, you have a compression option as well. So you have different compressions like gzip, snappy. So you can choose one type of compression depending on your business use case scenario. Okay, so if you prefer, more compression better than the IO input and output read ratio, then you can go for snappy. You have better compression. I mean more compression. It's optimized generally. gzip, yes, you have in compression but a lower I input and output ratio. So for different compressions have a read through, and then based on that you define your target configuration. Okay, above all, your IAM role plays a key part, because without IAM role you will not be able to access a particular job. So to do anything, you need necessary permissions, isn't it? So if you're trying to access a database, you need permissions to access the database. If you want to pull the data out of it, you need necessary permissions for it. Or if you just want to read it, yes, you need appropriate permissions. If you need to overwrite something on the database, yes, you need permission. So similarly, for any use case scenario within an ETL job, you need to set the necessary permissions. Okay, so what kind of permissions do you want? What kind of source do you need to access? And with a particular source, what is the activity you want to perform? What is the privilege you require? So depending on all of that, you define the IAM role for your particular ETL job creation. And then you have your job execution and monitoring. So in the job execution and monitoring part, first thing I would like to address is, you defined your source, that's fine. Next, you got your ETL configuration all set. Now, how are you going to execute the job and how are you going to monitor it? So that is what we'll be seeing now. So for the job execution, okay, you have two options. Either you can run it manually on demand, or you can schedule it and then run your job periodically. Okay, so what is the use case scenario for these kind of situations? If you're wondering, on demand is, for example, I'm doing some testing. Okay, I'm doing some testing, and I'm testing my code's efficiency, or I've changed a little bit and I want to check if my job can run. So all you gotta do is go for the on demand option. Okay, it's just like a click button, and once you start your job or run your job will be executed immediately. But what if you have your ETL code ready and you know that it's not going to throw out any error, at least for at least until the last time you tested it, and now you want the ETL job to run periodically, like for example, let's say for a batch processing, you might set like once in a day. So how are you going to schedule it? So you have options to schedule it. Do you want it to run every minute? Do you want to run it every hour? Do you want to run it for every once in a once in a day, once in a week, once in a month? So it all depends. So what is the interval that you prefer? You can schedule it. Then the monitoring part. Monitoring is a very important process because you need to know, for example, how many records were read first and how many records were processed and how many records were loaded later. So that is a monitoring strategy. You need to monitor to check if your job has run successfully. You need to monitor to check what is your resource utilization. You need to monitor to check what is the job progress. Is it successful or is it lagging or has the job failed? So, even you can check your cost. So, which resource has taken a lot of your cost? So, depending on all variety of reasons, you define your monitoring. All right. And then you have your error handling part. So you implement error handling within your job script or configure job retries to manage potential failures. So what do I mean by this? So for example, there is not a chance that you will be always having your code running successfully and your ETL job is always successful. There are scenarios where your job fails. There are scenarios where your job throws out an error. There are scenarios where your job has had a retry and it failed somehow. So under all these reasons, for example, you might have a schema evolution error, and if your job couldn't handle it properly, you might be thrown out with an error. Isn't that right? So if there is any seasoned professional, you would be aware about this, right? So how do you handle all these errors being thrown out? So you need to have all the error handling strategies already in place. So either in your script, or for example, let's say you can set your retry configuration. What do I mean by retry configuration? There are chances that, for example, when you have some network issues, your job might fail. Okay. And under that scenario, uh, you need to reconnect and then run your job again and again. So instead you doing it manually, you can set the number of retries. So you can set a number like 5. So each time the job fails, your job will retry until the number that you have specified. So for example, if you have set 5 is going to fail, then you have a retry. Second time it runs, it has failed. It tries for the third attempt. The job is successful, well and good. So it will have 5 options, okay, 5 retries to make sure that okay, your error is handled and your job is running successfully. So you need to have all these job execution and monitoring strategies in place. And then the data loading part, which is our final process of this ETL uh, design. So for the how you have source definition. Similarly, you need to have your target definition as well, or you can call it as target destination. So whatever the data that you have extracted and transformed. So once your job executes, you're going to have the final transform data. So what are you going to do with that? So you define where do you want to write it, on what format do I need it. So when you load the data finally, that is where your load phase of your ETL progress gets completed. So this is how, on a whole, okay, on a broad picture, it is the process of creating your ETL job. Okay, and so for example, different things in here define a different meaning. Okay, this is the reason I want to explain this image at the last. So this is our simple ETL progress, right? This is our data store, and from the data store you extract the data, and depending on the script that you provide, whatever the transform script that you provide, you transform the data and then you load it to your data target. Okay, but inside that you can see that I've got a data store. Your crawler crawls through the data and gets the metadata and puts it to a data catalog, and then based on your job your transformation runs, right? So you do this via AWS management console. And then also for your transformation script, you can schedule it or you can make it run based on an event. So this is a full big picture of the process of creating an ETL job from a source to an target. All right. Okay, cool. Off to our next question. How do you handle schema evolution in AWS Glue when source data schema change? This is some important question. Okay. Why is it important? First thing, let's talk about the schema evolution later. Why is it important? It is important because there are high chances, okay? There are high chances that your schema would get evolved. So, what do I mean by schema evolution first? I have a description for it, but for now, let me put it into some casual way, okay? Let's say you have a S3 data lake as your source. Every day, your data or your files gets dumped in there, okay? For example, in yesterday's file, just an example, okay, don't take it serious. So in yesterday's file, all you had was three columns, okay? So for that three columns of data, you extracted it, you transformed it and loaded it somewhere. What if, okay, what if, so in your website that where you put in all the information, for example, okay, what if a new row was added? I mean, a new column was added. So today's file type is going to have four columns and not three. I hope this is very clear, right? So instead of three columns, you had three columns yesterday, and now you are having four columns in your data or your file. Now you have your conflicting issue here. What is the conflicting issue here? Previously you had three columns and now you have four columns. So how are you going to deal it? So this is what we call as a schema evolution. And also one key thing, it doesn't just mean that addition of row. Even if you change the data format, even if you change the data type, even if you change, you know, whatever the changes actually, okay, in your file, that isn't schema evolution. So your schema is getting evolved, okay? So how do you handle it? Do we have strategies? Is there this option to deal with schema evolution in AWS Glue? Yes, surely we do have strategies to handle the schema evolution. So first thing, I've got a picture here. Okay. So what I'm trying to explain here is database schema evolution. So I've got a table here. If you notice, in the first one, I've got four columns. In the next table, I've got three columns. And the third table has almost five columns. Okay, let's not get into detail like what column is missing, what column has been added, but just notice that you had four first, then the three, and then you are having five. Under this scenario, how would you handle it? Okay, AWS Glue provides several mechanisms to handle schema evolution in source data, ensuring that ETL jobs and downstream applications can adapt to changes without breaking. So your AWS Glue, which is an serverless ETL tool, has several mechanisms, okay, to handle all your schema evolution problems. It might be from the source, okay, and even when extracting the data from the source or within your ETL phase, it will always ensure that even with all the schema getting evolved, your application doesn't break out but rather gets adapted. Okay, the first feature or first efficient way to handle your schema evolution issue is that by using AWS Glue crawler and data catalog. So how can they provide us with the handling of our schema evolution? The AWS Glue crawlers are designed to automatically infer the schema of your data sources. So whatever your sources, it can be an S3, it can be JDBC database, it can be a data warehouse, or whatever your sources. Okay, so your AWS Glue crawler are handled or designed in a way to handle the schema evolution. So your Glue crawler crawls through the data store. Okay, and when a crawler runs, it analyzes the data and populates or updates the AWS Glue data catalog with the inferred schema. So whenever the crawler runs, it fetches a metadata about the table definition, data definition, the schema definition. All right, it tries to get the information and automatically writes it to your AWS Glue data catalog. Right. So whenever the crawler runs, you are able to get the updated or the latest metadata about your data, and then you get it to store it into the AWS Glue data catalog. Okay, so each time when the Glue crawler runs, you're going to get a metadata, right? You're going to get an information about your new file, whereas 3 columns, 4 columns, or whatever it is. So you have an idea now. So if there is a schema update, if the source data schema changes, example, new columns added, data types modified, columns dropped. So under these kind of situations, running the crawler again will detect these changes and update the corresponding table definition in the Glue data catalog, therefore ensuring that metadata accurately reflects the current state of the source. So your Glue crawler, each time it runs, it will get an idea about the updated schema or the changed schema. So whatever it is. And even when updated, okay, it detects these changes and will make sure that the metadata repository is also updated. Therefore, you're you have an idea about the new data structure. You have an idea about what kind of data are you dealing with, how many excess columns are you dealing with. So you get all of this idea using AWS Glue crawler for your Glue ETL job. Then you have your AWS Glue dynamic frames. In our previous video, we learned about the AWS Glue dynamic frames and Spark data frames, right? And dynamic frames comes with advanced features that are not present within your Spark data frame. So the first thing with your Glue dynamic frames is that you get schema flexibility. So AWS Glue dynamic frames, which are key abstraction in Glue ETL jobs, are inherently schema aware and designed to handle schema evolution that can automatically adapt to schema changes when reading data without requiring explicit schema definitions in your job script. So if you use AWS Glue dynamic frames, okay, they are schema aware by default, and therefore they can handle the schema evolution better. And because they are aware, they can automatically adapt to your new schema changes. And then you no need to provide any explicit schema definitions. Okay, so that is one key benefit there. Then you have resolve choice method. For more complex schema evolution scenarios, such as data type mismatches or conflicts, dynamic frames offer the resolve choice method. This allows you to specify how to handle discrepancies such as casting data types, dropping conflicting columns, or selecting a preferred data type. So, in the glue, you have an option called as resolved choice method. Okay, and you use resolve choice method to handle your schema evolution. And what does it do when it sees a different kind of schema getting evolved? So what this does is that it can handle the discrepancies. So if you're having a conflict in casting your data type, you have conflict in columns, you have changes in your data type. It knows how to handle it when there is a mismatch. Okay. Then you have AWS Glue schema registry. So this schema registry is nothing but it has the information about your schema. So all your previous schema informations, they get registered in your AWS Glue schema registry. By definition, the AWS Glue schema registry provides a centralized repository for managing and enforcing schemas for streaming data. So streaming data is usually from Apache Kafka. If you prefer AWS tool, it is Amazon Kinesis. So for these kind of streaming data, you need to know about the schema, right? You don't want to have any wrong kind of data or wrong kind of schema getting stored up. So this schema registry, what it does is that it stores all the information, okay, about your not all the information, the schema information about your data. And also there is a possibility of you enforcing a schema type. And not only that, your glue schema registry also can store these schema versions. It allows you to define and it allows you to define and version your schema. So whenever there is a schema change, each time it gets updated. So for example, first version, second version, third version. Therefore, ensuring compatibility between different versions, either with the backward one or with the forward one, or is it completely compatible with all the schema versions? It depends. This helps prevent data corruption or application failure when schema changes occur in streaming pipeline. So what is the default action when your schema gets changed or altered? There are chances that you might have an application error, an application failure. So when you have all your versions stored in your glue schema registry, the chances are less. Okay, because you have all the versions in place, you stored it, right? And therefore you know how to handle the compatibility, how you know what is the compatibility between these versions. Then you have ETL job design consideration. Resilient transformations. When designing Glue ETL jobs, it is important to build in resilience to schema changes. So, whatever your ETL job is, you have to ensure that it is in resilience. Okay. What do I mean by resilience? It must be able to handle the changes. So when there is a change, we don't want the system to fail, right? We don't want the application to fail. So for these scenarios, your ETL job must be designed in a way that it can handle all these schema changes. This might involve using flexible data transformations that can gracefully handle the presence or absence of columns, or using conditional logic to process data based on the schema version. And then you can use job bookmarks. Okay, job bookmarks. For incremental data processing, Glue job bookmarks can help track the state of processed data, ensuring that only new or changed data is processed, which can be particularly useful when dealing with evolving schema. So if you're wondering what is an incremental data processing, for example, let's say I have 10 rows today and tomorrow there is like another 10 transactions. So now I have total of 20 rows, right? Now when I process this for the first time, all my 20 rows get processed. And now let's say next day, I'm doing another 10 transactions. So now I have total of 30. I've already processed 20 transactions and I don't want to process the 30 transaction as a whole, right? It is not efficient and it is not a proper or an optimized way. So what do I need to do? Leaving all my 20 rows behind, I need to only process the incremental or the latest 10 rows. So that is where your job bookmarks come into play. So when you select the job bookmarks option in your Glue job, you can track the state of your processed data. Therefore, you are ensuring that only your new data is processed but not your old data. Okay. And this is particularly useful when you are dealing with evolving data schemas. So by combining these features, AWS Glue enables to effectively manage schema evolution in data lake and ETL pipelines, minimizing manual intervention and ensuring data consistency and reliability. Okay, so these are the strategies you can have to handle your schema evolution explicitly while using only the AWS Glue tech stack. Next, how can you customize the ETL code generated by AWS Glue? When you define your Glue job, okay, your Glue, okay, it can automatically generate an ETL code, and these code are always into the Glue script editor. So how are you planning to customize it? Because your Glue has generated a script and you need to customize it, right? So when you customize, you have more control, you have more better control of your data, how you want to handle the data, what is the transformation that you want, what is the kind of you know uh, transformations, or what is the type of loading that you need to perform, what is the compression that you need to set. So all these kind of different kinds of customization, you need it, right? And how do you do it? Okay, very simple. At first, okay, I'll read this and then I'll go to the first part. AWS Glue provides several methods to customize your ETL code it generates, allowing for tailored data processing workflows. Okay, at first you have direct code editing. So, where does your code gets generated? Where does it get stored? It gets stored in your AWS Glue console script editor, right? Okay. So, when you have your data in your Glue console script editor, what you can do is, I mean, it is our first initial ETL script generator, right, from our Glue. And it can be either in Scala or Python, and depending on our job configuration. So what you do is, directly in the Glue script editor, you can modify the code according to your business requirement. And by doing it directly, you manage to do fine grained adjustments according to your transformation logic. So also you can add custom functions, you can look to optimize your performance. So for different kinds of setups, you can just modify it directly. And of next, you have download and edit locally option. So what you do in this, you download the auto generated script and edit in your preferred IDE. So for example, for Python, we have PyCharm, right? If you're using Scala, you can use the compatible IDE of your choice. So you download the script, open those file in your preferred IDE, and you modify it there. And one better of you using your local IDE is that you can run tests. Okay, and this provides you with more robust development environment with features like code completion, debugging, version control. When you do it directly in your Glue editor, your Glue script editor, you don't have options to maintain the history, right? You don't have options to keep the all your code versions there. But when you do it locally, you can connect your ID with an version control. For example, GitHub, a Bitbucket, whatever you want of your choice, right? Or depending on the business, you connect to it. You can version control it locally. You can test it locally. You can debug with multiple libraries and modules of your choice. All these kinds of features, or added bonus when you try to perform, when you try to modify your script locally. And once after you finish your editing, you can just upload your script to the AWS Glue, and your Glue jobs will take the script and will run the job as per your script. All right. Next, custom libraries and modules. You can import custom Python libraries or jar files, and then you can run your AWS ETL job. So what do? You import all your, preferred Python libraries or a jar file. Jar file is nothing but a Java archive files. So you just can download them and import and use it into your Glue ETL job. This enables you to leverage existing code bases, specialized algorithms, or third-party tools within your ETL process. By using different Python libraries or a jar file, it comes up with a code base, right? You get an pretty much a big information, large information about what the particular jar file can do, how you need to modify it, what are the changes that you can expect. If you need to use for your certain use case, this is the algorithm that you need to go for. Depending on all those kind of features, you can just download and import your custom library and modules and then perform your ETL job. Then custom visual transforms. So if you're not of a type of using your code, then you can go for a visual interface. This visual interface is found within your AWS Glue, and it is called as AWS Glue Studio. Okay, this is a component within your AWS Glue. Not component exactly, but this is like a feature within the AWS Glue. So AWS Glue is it's a broad picture. It can perform ETL, and this is a visual interface within your Glue tool. Okay. AWS Glue Studio allows you to create custom visual transforms. You can define the structure and behavior of your custom transform using a configuration file like JSON, and implement the transformation logic using PySpark code. So what you do is, within your AWS Glue Studio, okay, you have options to create a custom visual transform. So all you do is you just drag and drop all the transformations that you want and map it to your current ETL pipeline. So once you have mapped, all the process happens like as it how it runs in your local, not local, as it how it runs in your Glue job. Okay, so instead of code, all you're doing is you're using a visual interface. And also you can convert the particular Glue Studio code into an PySpark code. You can integrate into visual jobs. The custom transforms can then be used as a drag and drop components within the usual ETL job editor in Glue Studio, promoting reusability and consistency across different ETL pipelines. So this is what I just heard. I said earlier. So you define your job or you design your job using a visual tool, not just using the code. Okay, so you can also change it. You can also get your visual interface into a code format as well. So vice versa it works, and you can modify your Glue generated script. Or you can start from a sample code. If you're wondering where can I get a sample code, if you're a fresher, yes, you will be having doubts. You can get all kinds of sample ETL codes from GitHub. Okay, so not only GitHub, I mean, within GitHub, it's not just the third party vendors or third party persons. because there are multiple peoples who just put their code into the GitHub and keep it for an open access. But if you don't find a proper one, do not worry. AWS itself has a repository of sample ETL scripts. So you can find it in the GitHub. Just put keywords like AWS Glue, ETL, GitHub, and you will be able to find the repository. So you can start with those samples, and then depending on your use case scenario, you can customize it, and you can try to fit into your business use case. And therefore, it provides a solid foundation for complex transformations. Utilizing AWS Glue custom ETL library. So AWS Glue provides a custom ETL library that simplifies interacting with data sources and managing job execution. Utilizing this library within the custom code ensures efficient and optimized data handling within the AWS Glue environment. So your AWS Glue tool, it provides you with a custom ETL library. Okay, so you can try to use the ETL library provided by your Glue. Therefore, you can simplify your interaction with data sources, and you can manage how your job gets executed. So along with your code, whatever you have, if you use the library, it is going to be more efficient, and you're going to get an optimized way of running your ETL pipeline. Okay, so I hope that is all for today, and this session was very beneficial to you. And just before we close, let me explain this picture once so that you get a better idea. So if you see this image, okay, so which part are we dealing with? So you have your data store here, crawler here, data catalog, and you get an pretty much an metadata repository from your data catalog, and that acts as your source definition. Okay, okay. This is the part that we are talking about, the transform part or your script part. Okay, so you define it. How do you want to use it? So if you get the script generated, you can either download it, change it, or directly change it, or use AWS Glue libraries to change and customize the code depending on your business use case. And then when you provide it, your job, when it gets executed, takes the script and then does your ETL job properly. Okay, so you provide the script and rest happens. So there are multiple ways, and you can modify or customize your code depending on your use case scenario. So what are the things that we learned today? We described the process. Okay, the keyword here is process. So we learned about the process of creating an ETL job from a source to target. Also, we learned how to deal with the also we learned how to deal with the schema evolution. Then also we learned how to customize the ETL code that is generated by the ETL glue. So I hope this session was very beneficial to you, and I hope to see you in the next video. So before we close, who are we? We are Data Valley, the fastest growing edtech company of 2025, and we offer you with IT solutions, trainings, and placement support. So, for any kind of purpose or learning you're looking for, we as an institute are very passionate towards your career progression. So, feel free to reach to our website at datavalley.ai, and then to any of our colleague. Any of our colleague will be more than happy to help you in your learning journey. And one key thing I would like to address here is our learning sessions. Okay, it's not just being taught in English. If you are of any regional speaking people like from Tamil or Telugu, we have channels for Telugu and Tamil as well. So feel free to check out those channels, and we post regular contents there. And we have our headquarters in UK, US, and in Hyderabad as well. So we have 4 centers in Hyderabad, and if you're someone living close by, feel free to check out our company or ring to the particular number, and they'll be more than happy to guide you in your career progression. And we are soon expanding to multiple places like Chennai, Bangalore, Delhi, West Bengal. We have plans, and soon we are progressing into different areas of our country. So do give your support, like this content. If you have any questions, drop your questions in the comment section. Also, do not forget to share with your fellow friends who are preparing for their data engineering interviews. And I believe this video will be helpful to you and your friends as well. Good luck with your learning. And if you have been successful in your journey, do share your success story in the comment section, or you can reach to us in the LinkedIn, and we'll be more than happy to take your appreciation. And if you have any suggestions for us to improve our teaching modules, feel free to drop your suggestions as well to our mail ID or in the comment section as well. We are more than happy to take it. We are open to it, and we learn from it, and we will come with better study materials for you. Okay, so thank you. This is Franklin signing off. Until I see you in the next video, bye bye, take care, see you in another video.